Welcome to Disco Magic, where life is together is magical. Answering question 15. This time the diagram, you have a pulley here. It's connected to a mass, a barrel of 120 kilograms. Then you have it connected to a string here, which connects to the ground to a stick. And you have 18 meters, as to the 18 meters here, and you have a man here of 80 kilograms. Mass of man equal to 80 kilograms. The diagram shows the barrel suspended from a frictionless pulley on a building. The rope supporting the barrel goes over the pulley and secured to a stake at the bottom of the building. A man stands close to the stake. The bottom of the barrel is 18 meters above the man's head. So around here, the mass of the barrel is 120 kilograms. The mass of the man is 80 kilograms. The man takes hold of the rope after untying it from the stake and lifts it outwards as the barrel falls. Okay, this is like a Batman, episode of Batman where he's able to propel himself upwards with a object that's heavier than him, therefore accelerating. So, what is the man's upward speed when his head is level with the bottom of the barrel? The key to this question is actually a trick question, is to realize your correct second diagram. The correct second diagram is they want to know what is the velocity of the man when something like this happens. When these two are of the same height. So, okay, when it's attached to the thing. So let's read it again. What is the man's upward speed when his head is level with the bottom of the barrel? When they are of equal position, what is his V vertical of man? So we got all the information here. Here they said please use G as 10 meters per second. So here, this question asks you to use specifically 10 meters per second. But under normal circumstances, do not use this unless it's stated. Okay. Here they say please use 10 meters per second. If not, we should use 9.81 meters per second. The key is this diagram here. 80 meters. What most students will do is use the value of s equal to 80 meters. But yet remember, when this barrel goes down, the man goes up. So when they are aligned, is it really 80 meters? No, you realize that it only actually moves 9 meters. So from the original position, the only motion, the s real will be 18 divided by 2 equal to 9 meters. So this is your real distance. So let's begin our UV set line, because it looks like a UV set question. So UV set. U, initially 0 meters per second. We had to find V. S here correctly is 9 meters. We need one more information, so probably it will be A. First question asks, previous few episodes, is this guy moving upwards freely? No. Okay, he's not moving freely. His acceleration is due to this object here. Means, careful, this is not just a UV set question. It's not kinematics only question. It's kinematics plus dynamics question. This we need to use forces. So let's draw a force diagram. The man is 80 kilograms. He has a weight of 80 times G. What is happening here? He's being propelled by this object. Okay. So if you actually draw weight of the barrel, if you go over here, you notice weight of the barrel is in this direction. Okay. His weight is going downwards, but weight of the barrel is upwards. So it's 120 times G. So begin our equation. Resultant force is equal to MA. take direction upwards to be positive. What is actually causing the man to actually go upwards is due to the weight of the barrel. So you got weight of barrel. It accelerates at the same pace as the man. So this is total mass and total acceleration. So in this case, you got A total, where barrel is 120 G, total mass is 120 plus 80. Again, if you notice the mass, what you see is 120 over 200 times 9.81. 0 cancel. You have divided by 4, divided by 4. 12 divided by 4 is 3. 20 divided by 4 is 5. So, acceleration is 3/5 of A. Now you got your A already, you can use your V set time, V as AU, which is fifth equation of motion. So V squared equal to U squared plus 2ns. This is equal to 0. V equal to 2ns square root 2 times your acceleration 305 times 9.81 times your displacement here, which is 9 meters. Okay, click, click, clack, clack. And hopefully you will realize something is wrong. What do you mean by something is wrong? When we did with the previous two questions, when you have a table, a pulley here, this object weight is perpendicular to direction of motion. Means that this weight has nothing to do with the direction of motion. In this case, with the weight of the object here. But you have to be careful with this question. When you draw the force diagram, you realize my weight of barrel. Yes, the weight of barrel is pulling up. But if the man was weightless, this will pull up way, way faster. If you have a small little feather duster attached to this instead of man, it will fly, accelerate way faster. But now you have a man. So will the man accelerate as fast as the feather duster? No. Okay? So you have to be careful in instances like this, where the direction is not perpendicular to the weight of the man. Remember, this is the direction of motion. It is not perpendicular, means this does affect this. This is not perpendicular to this motion, means it also affects to it. Okay. That's why you notice gap here. So once again, if you did a mistake when doing revision, just cancel nicely. And then you write your correct equation. So in this case, it is weight of barrel positive, weight of man negative, equal to M total, A total. So A total here will be equal to weight of barrel 120 times 9.81 minus 80 times 9.81 over 120 plus 80. In this case, you understand why they ask you to use 10. Okay? So if you use 10 here, 120 minus 80 is 40. 40 times 10 is 400. 400 over 120 plus 80 is 200 times 9.81. So when you're doing revision, if it's wrong, just cancel it nicely, and then you time it with the correct information. Time the correct displacement, and I give you a few seconds to follow this. Hopefully, you get the answer. While I check what the answer would be. And the answer is 6 meters per second. Please double check this again. Remember, I do have a calculator here. So if this number is wrong, please update to me, feedback to me. I hope you understand this video. If not, please replay this video. Okay.